It's okay. We have like 20, we have about 26 students or 25 students present.
Yes,
So
sir.
it's surprising that told me that you are 30 students. Over the years, we've been teaching close to 80 students because some students do come from chemistry, and also we have direct entry students that are taking this course. So if you say it's 30, then probably the admission is quite low. Yeah.
Well, more than 30, sir.
All right, no problem. So we are going to start. But it's unfortunate that the class rep is not around, and yeah, he has been organizing these classes for a while now. So I'll be taking you through. Yeah, you want to say something?
No, so I said, what's sorry, sir. Good afternoon, sir.
Yeah.
Yeah, the course is around, sir. Is here.
Okay. Yeah, class rep, please. I was asking the amount of students taking this course. How many students? What's the average amount of students taking this course?
About 100.
Sir, everybody.
Yeah, I don't know your population. First time I'm meeting you people, I don't know your population. So that's what I'm asking.
We are like 90 or 100, sir.
Okay, no problem. So, but right now we have 26 students. I am very sure you already told them that there's going to be class.
Yes, sir. I told them.
All right, thank you. So,
yes, sir.
I am Dr. Odile, and I'm in the engineering part in the Department of Geology. I'll be taking you through the origin and the characteristics of the atmosphere and the hydrosphere. Please, there's a student that is yet to mute his or her call. Kindly mute, please. You have time to talk to your friends after the class. In order for us to be able to get what I'm trying to say, please, I will urge you guys to please mute your system until you're asked to do so. Able to talk. So, I know you are coming from either you have been to the Polytechnic before, or you have been in a place where you have been taught about atmosphere and the hydrosphere. So, with this introduction to geology, we are going to take you through several topics. And my own topic is the origin and the characteristics of the atmosphere and the hydrosphere. But before I delve into that, I would like to tell us what geology is. I'm very sure Professor Akimosi must have introduced to you geology. Probably other lecturers must have come to tell you about geology because it's your first time having this course. So geology as it is an applied science. What do we mean by that? Geology is not a course that stands on its own, but relies on other sciences to get its own fact. So geology studies the earth, but uses physics, chemistry, biology, engineering to study it. So that's the reason why we hear geophysics, meaning they are using the principles of physics to study geology. You can hear geochemistry. They are using the principles of chemistry to study geology. You are going to hear something like economic geology. They are using economics to study geology. Why economic geology? Because geology uh, deals with natural resources, and of course, natural resources are to be sold. And before you decide to sell a natural resources, you must understand if it is good enough for business, if the natural resources is viable for you to do business with. So that's where you can apply economics into geology. So we have several sciences that we use to study this. And of course, as you go higher, we are still going to teach you things like engineering geology, hydrogeology. We are applying the study of engineering into geology. So geology encompasses everything that is science. It borrows the tools of science, other science, to study the rock. So geology is an applied science. And of course, we have rock. So you people will be studying rocks. You go to the field, you will see outcrops. We call them outcrops. Any rock you can see is called an outcrop because it is from beneath the subsurface. So you can see some part of it at the surface. Those parts that you can see are called outcrop. So what is a rock? You cannot study geology without understanding what a rock is. A rock is an aggregate of minerals. So a rock is comprised or is constituted of several minerals. So this rock now, over a very long period of time, will now weathering process. So this weathering process will affect the rock and will make the rock now change from its original state to what is called a soil. So we have several kind of what's it called, weathering. We have the physical weathering. If you take your hammer and you try to break a rock into chunks, what you are doing is a physical kind of weathering. So you have the chemical weathering, where you talk about oxidation and reduction. From what I've just said now, you know that there's chemistry in geology and there's mechanics in geology. Because if you do physical hammering, you're talking about mechanics, that's the rock mechanics. So you are going to apply several sciences to study what geology is. So when you talk about the atmosphere, you are talking about something related to geography. So you are going to use geography to study what the earth is made of. Though the earth, as it is one of the planets, and of course, human life exists on the earth. And without all these gases we are talking about, life cannot survive. So it's very important that we study those things that keep life, that keeps human or every living thing alive. And those are the atmosphere and the hydrosphere. The hydrosphere encompasses the liquid portion of the earth, while the atmosphere is the gaseous portion of the earth. So we are going to talk about the origin and the characteristics of the atmosphere and the hydrosphere. So now you can see from the picture, the atmosphere is just gaseous because it is transparent. Enola Adesisayo, can you please mute? So the atmosphere is something that is very plain, but because of human activity, you might observe that the atmosphere is not as clean as I have said, because of what we do, the industries. The industries we produce a lot of pollution, and it will now contaminate the atmosphere. It will contaminate it physically, and of course, in its constituents. And of course, it might affect life. So in this course, when we tell you, we talk about atmosphere. In geology as a whole, we study it because everything about geology is about the earth and how it operates. And of course, if it does not affect life and property, then geology is useless. So we are studying all this because we know that if there is any form of disaster, and if it's not properly studied, it will affect life and property. So those are the significance and the reason why we need to study it. So before you study anything, you should know why you are studying geology. Most of us came into geology not because we want to study geology. Most of us don't have an idea about geology. If we are being asked by people around us that what's your course, what's your major, I tell them geology. If they ask you what is the significance of this course you are studying, or why do we need to study rock? What is rock? What is the significance of a rock? You might be stuck and you might not know what to say. Rock as it is soil, is the antidote of rock. So, and soil can be used for agricultural processes. Soil can be used for construction processes. Even the rock aggregates can be used for construction processes. Like, you can see aggregates like the granite for construction purposes. So the rock and the geology encompasses every aspect of life. You can, as a matter of fact, when you get to a particular level, you'll be taught medical geology. So in medicine, also geology is very important. So the atmosphere is the thin gaseous layer that envelopes the lithosphere. So when you hear the lithosphere, you must have, I don't know, probably you have been taught what makes up the Earth, the internal structure of the Earth, where they will tell you that the Earth is comprised of the core, and the core is divided into two. We have the internal and the outer core. If you talk about the layer that follows the core, which is the mantle, we have the lower and the upper mantle. Then we talk about the crust. So the crust now has the lithosphere and the asthenosphere. The lithosphere is the surface you are seeing, while the asthenosphere is the lower part of the lithosphere and the upper part of the mantle. So when they talk about from what is written here, it's written that the atmosphere So when we talk about this definition now, it says the atmosphere is the thin gaseous layer that envelopes the lithosphere. It's a way of telling you that the atmosphere is just on the surface, not within the subsurface. So the present atmosphere is composed of 78% nitrogen, 21% oxygen, and 0.9% argon. The trace amounts of other gases. We have other gases, but they are they are trace amounts. They are trace amounts. So the most part of the atmosphere is the nitrogen, which is 78%, and 28%, 21% of oxygen, and 0.9% of argon. So that's what the atmosphere is made of. So since we are going to be talking about atmosphere and hydrosphere, I'm going to define what an hydrosphere is. It's the dynamic mass of water that is continuously on the move. We have water, and of course, the earth is made up of several components. On the earth, the water is the most abundant component of the earth. We have water well distributed on and beneath the earth. Within the subsurface of the earth, you have a lot of water. So about 70% of the earth is covered with liquid water, which is called the hydrosphere. And much of it is in the form of ocean water. Only 3% of Earth's water is fresh. 2/3 are in the form of ice, and the remaining 1/3 is present in stream, lake, and groundwater. So we have what is called the hydrologic cycle. Hydraulic cycle is the precipitation, evaporation, runoff, and infiltration. What is precipitation? Precipitation is a form of rainfall. Water gets to the earth, then water is sent back to the earth by the process called evaporation. When water gets to the earth's surface, during the raining season, when you have heavy rainfall, you will see water running through drainages, through the surfaces. As you go on in the course of geology, they will mention some things to you like porosity, permeability. I'm not sure if you have heard about it before, but I'm going to explain to you because I'm going to talk about runoff and infiltration. You see, porosity, a soil mass, or a rock, they contain some space which is called the pore spaces. That's the reason why they can allow water to pass through them. If you have a metal and you put water on the metal or in a plastic container, the water will remain in the plastic container because the container is not porous. If you have a drying towel, the towel that you use in drying your body, if you have water on it, the water will get soaked in the towel. Why? Because the towel is very porous. It has a lot of spaces in between it. So the soil and the rocks are porous material. So, but if this rainfall is very, very intense, all the water will not be penetrating into the soil because the pore spaces are very small. Some of the water will penetrate into the soil, will infiltrate into the soil, while most of the water will run across it. It's just like you opening your mouth. There are some water that when you open your mouth and you take a sachet water, it will all go into your mouth. But if you go to a very big tap, a very huge tap, or a very huge tap which is bigger than your mouth, you can open your mouth to the tap, but most of the water will not get into your mouth or will flow away because your mouth cannot take the water. That's how it applies to rainfall. When the intensity of the rainfall is so high, the pore spaces cannot receive all the water. They will take the ones they can take, and the remainder will now flow as runoff. That is what is called runoff. Those water you see flowing around within the drainages, the surface of the soil. Because you might want to ask me, since you said that the soil is porous, they have pore spaces, why is water running off? It is because the pore spaces are very, very small. If the rainfall if the precipitation is like a snow, most of us, maybe some of us must have been in a country where we see snow. A snow will remain there. It will not flow. All the water will take their time to seep into the ground. It will infiltrate into the ground. So snow can increase the groundwater, can increase the water within the subsurface than heavy rainfall. So that is that's what runoff is. When I was talking about runoff, I mentioned that some water will infiltrate into the soil. The process where water gets into the soil is called infiltration. So now I believe that you know what precipitation is and what evaporation is. Also, you can explain what runoff is and what infiltration is. So these are the four things that make up the hydrologic cycle. Yeah.
Are you there, sir? Are you there?
I think he's muted. He's muted. Yeah, so we can't hear you.
I know you cannot
Are
hear
you
me.
there, sir?
I can hear you. I asked you to hold on. I attended to something.
Okay.
Yeah, Abdul Alatishe, you are raising up your hand. Is there any question?
Yes, sir. Good afternoon.
Yeah, good
So
afternoon.
please, can you continue with the definition of precipitation?
Precipitation is rainfall or snow.
Okay, sir.
Yes. Then evaporation is the way the water is sent back to the atmosphere when there's sunlight. there's evaporation. If it's going out of the tree or plant, it is called evapotranspiration. If it's just going out from, if you are boiling water, you can see some gaseous form. Those forms, when there's heat, they will go back to the atmosphere. So that's precipitation. Precipitation is either rainfall or snow. Evaporation is the way that this water go back to where they are coming from. Then runoff is when you have a very high, where you have intensive kind of rainfall. Some will infiltrate into the ground, while the rest will go as runoff. So that's the process. And you might not see runoff if the rainfall is of low intensity, maybe just dropping like drizzling. Every of the water will just be seeping, will be infiltrating into the ground. That's the reason why I mentioned to you that the rainfall must be very intensive before you can see what runoff is. So now this is a kind of hydrologic cycle, and it's a way of showing you that before you say something is cycle, it is cyclical in nature. It can never diminish. Water cannot diminish. It will always go in cycle. When you use your water, when you pour water on the ground, it will go back to the atmosphere by the process called evaporation. So water cannot diminish, and that's the reason why we still have water. So you have condensation, precipitation, evaporation, transpiration, infiltration, surface runoff. Condensation is when the water go back to the atmosphere, it gets condensed, then it fall back as rainfall through the process called precipitation. So those are the very important terms that you need to know. So the Earth is believed to have formed about 5 billion years ago. In the first 500 million years, a dense atmosphere emerged from the vapor and gases that were expelled during the gassing of the planet's interior. When we talk about planets, you know we have 8 planets, and the Earth is one of the planets. So within these planets called Earth, some gases were brought out. So that's where the atmosphere began to form. So during the cooling of the Earth gases, the water vapor were released from the interior solid part of the Earth. This started the evolution of the present atmosphere. And this process is called degassing. So when you hear the word degassing, you should be able to explain that it is 500 million years ago, a dense atmosphere emerged from vapor and gases that were expelled during the gassing of the of the Earth's interior. During the cooling of the Earth, gases and water vapor were released from the interior solid, and the process is called degassing. So these gases may have consisted of hydrogen, water vapor, methane, and carbon dioxide or carbon oxide. Prior to 3.5 billion years ago, the atmosphere probably consisted of carbon dioxide, carbon monoxide, water, nitrogen, and hydrogen. So the atmosphere was formed 4 billion years ago from the condensation of water vapor, resulting in ocean of water in which sedimentation occurs. You must have heard, I don't know if you have been taught about rocks already, you must have heard about igneous, metamorphic, and sedimentary rock. But that's not the case here. What we call sedimentation, when you are drinking your gari, you try to stir the gari in water. At some point, you will see that the water is at the top while the gari has settled down. So that process of settling is called sedimentation. So the gases were haphazardly flying with other sediments. So when these sediments now settle, it's called sedimentation. So they form another layer. The most important features of the ancient environment was the absence of free oxygen. Evidence of such an anaerobic reducing atmosphere is hidden in early rock. I like to explain to you some words that I think you might not understand, but I know for sure that you were taught anaerobic and aerobic reaction in biology in your high school. When you see the word anaerobic, they're talking about lack of oxygen. So the process of lack of oxygen, evidence of such an anaerobic reducing atmosphere, that is lack of oxygen atmosphere, is hidden in early rock formation. You know, geologists, they use dating to understand what has happened in the past. Have you been taught the principles of geology, all the principles of geology? Has any lecturer taught you that?
No.
No, sir.
No, sir.
It will be very difficult for me to explain that to you. That's not my part. But where you are going to be taught the law of uniformitarianism, the law of original horizontality. You're going to be taught the law of superposition, a lot like that, cross-cutting law. You're going to be taught in other level. So the law I'm going to use now is the law of uniformitarianism. And the law of uniformitarianism states that the present is the key to the past. So what is occurring now will tell us what has happened in the past. So that's the method we geologists use to know what has happened in the past. But in engineering, engineers will tell you that